Okay, there's a common theme that runs throughout the entire course of Math 3, which is looking at a function, usually it's a function, looking at the parent graph and then seeing how the graph changes by doing different things to the equation. So we're going to spend just a little bit of time making sure you guys understand parent graphs. Now the first one is simply the linear equation y equals x. I don't want you to make an xy table because if you did it'd be really easy. All this is saying is literally the x and the y values are the same thing. So the key point of this graph is 0, 0. And then you think the other points would be 1, 1, 2, 2. Down here, -3, -3. And anyway, what you'll wind up getting is a nice line going straight through 0, 0, and it passes through the origin. Now, domain and range of this function. Domain refers to the x's, so since it goes to the left forever and to the right forever, it would just simply be -infinity to +infinity, or another way of saying it would be all real numbers. Now the exact same thing happens with the range, which is the y values. It goes down forever and it goes up forever. So again, we're looking at -infinity to +infinity, all reals. So that's kind of the most basic one that you can get is just a regular old linear equation through 0, 0 with a slope of 1. The leading coefficient is that invisible 1, and that's why the slope is 1. Now the next one, y equals x squared. That's a quadratic equation. It makes a parabola, but again, if you think about the xy table, when x is 0, y is 0, so its key point is also 0, 0. When x is 1, 1 squared is 1, y is 1, so we got that. But this time when x is -1, -1 squared is +1, so -1, +1 looks like that. And so we're looking at a parabola that does something like that. Now, one of the characteristics of a parabola, such as this one that goes up, it goes up forever, but it also gets wider and wider and wider. So as far as the domain is concerned, it uses all of the x's. So again, we've got -infinity to +infinity, or all reals. Now, on the range, we got something a little bit different going on here. This parabola has a minimum value at y equals 0. So that's the lowest point this parabola reaches. So how we show that, we use a bracket, and we put 0 right there. Now the purpose of that bracket right there is to say this graph really does touch 0. But on the high side, it goes up forever and ever and ever to infinity. And so another way of writing that would be the range is all y values greater than or equal to 0. Now moving on to the next one, the absolute value linear equation, y equals absolute value x. Now the absolute values mean, when you put that x in there, if it's positive, it stays positive. If it's negative, it turns positive. So we're still looking at 0, 0. Again, if you think of an xy table, when x equals 0, the absolute value of 0 is 0. When x equals 1, the absolute value of 1 is still 1. So 1, 1. But when x equals -1, the absolute value of -1 is +1, so -1, +1. So it's kind of acting like a parabola with the exception of what the graph looks like. This is linear. So this just goes like this forever and ever, and this goes like this forever and ever. Now the domain, again, the values of x that are used by this graph range from negative infinity to positive infinity for all reals. The values of y, again, the lowest point, the minimum point of this absolute value v is 0. So, and we do include 0. So 0 to positive infinity, or y is greater than or equal to 0. Now, the last graph. This is the one people have a little bit more trouble with, the exponential growth graph, and the parent equation of y equals 2 raised to the x power. Let's actually make an little xy table on this to see what's going on. So when x is 0, 2 raised to the 0 power, anything raised to the 0 power is 1. So the key point is not at 0, 0 like all the others. This one's at 0, 1, which is right here. Now when x equals 1, y equals 2. So 1, 2. Now the interesting thing is, how about the negative? So when x equals negative 1. 2 to the negative 1 is 1/2. So negative 1, 1/2 would be about right there. So the characteristics of this graph is the fact that it's growing on the right-hand side exponentially. It doesn't have a constant slope. But on the left-hand side, it's getting closer and closer to the x-axis, but it's never going to touch that x-axis. So domain, forever to the left, forever to the right, because not only does it go up forever, but it also keeps opening out forever. So negative infinity to positive infinity, or all reals. Range. Remember what we said about this x-axis. This x-axis is what we call an asymptote. It's a boundary. This graph gets closer and closer and closer to that red dashed line that I just drew, but it never touches it. So the asymptote is y equals 0. The equation of the asymptote is y equals 0. And the range of this graph is, it gets closer and closer and closer to 0, but it never touches it. So we don't use a closed bracket, we use an open parenthesis to say it gets closer and closer and closer to 0, but it never touches it. Now, on the high side, it just keeps going up forever and ever and ever. So another way of writing this would be the range values of this graph are all values of y that are greater than 0. Notice it isn't greater than or equal to 0 because it never touches 0. And that's kind of the introduction to what Objective 1 is all about.